Hello ACT preppers, welcome back to the ACT preparation course. Today we're talking about imaginary numbers and we're going to do 4 practice problems. So real quick, before we get into the problems, let's talk about the concept. Imaginary numbers are just like what they sound. They're not real. Their definition is that they're the square root of -1. You can't have a negative square root, so that's what makes them imaginary. Now, for the ACT, you need to know 2 things. The first thing is the pattern of I. You have I is equal to the square root of -1. I squared is equal to, now think about it, square root of -1 squared is just going to be -1. I cubed is equal to -I, and I to the 4th is equal to 1. The second thing you need to know is what's called multiplying by the conjugate. First thing you need to know is how to find the conjugate. The conjugate of a term goes like this. The conjugate of a plus b is equal to a minus b. If I were to give you another problem like the square root of x plus 1, the conjugate is going to be the square root of x minus 1. The second thing you need to know is how to apply it. You might be given a term like this, 1 over the square root of x minus I. The first thing we need to do is find the conjugate. Well, the only terms so the conjugate of the square root of x minus I is the square root of x plus I. Now keep in mind, this term is something you are given. You can't change the term fundamentally. You can only multiply it by 1. So if we're going to multiply this term by 1, we have to multiply by the square root of x plus I over the square root of x plus I. Lastly, we might ask ourselves, why do we need to multiply by the conjugate? The purpose of this is to simplify. So if we take our terms up here and we multiply them together, this is what we'll get. Square root of x plus I in the numerator. The juicy parts are in the denominator. So the denominator, skipping over some of the foiling, we get x minus I squared. We know that I squared is equal to -1. So I can change I squared into a -1. I'm subtracting it from x, and now for our final simplification. As you notice, there are no square roots and no i's in the denominator, and that's why we multiply by the conjugate. With that said, I think we have enough information to go ahead and do the practice problems. Starting it off easy with the most basic I problem that you can get. For the complex number I and an integer n, which of the following is a possible value of I to the n? So I to the n is going to be equal to what? It's going to equal one of these things. If you think back to our preparation, or if you're familiar with imaginary numbers, you know that the only possible value is b, 1. However, let's walk through the steps. I to the 1 is equal to the square root of -1. I squared is equal to -1, right? I cubed is -I, and I to the 4th is equal to 1. So I to the 4th is going to be b. Number 2, in the complex numbers where I squared equals -1, so this is equal to what? And I'm going to write it out real quick. Okay, so we're given 2 problems. I want to point out the conjugate real quick. Here you have a 1 plus I. Over here the conjugate, 1 minus I. Starting with the numerator, 1 times 1 minus I is 1 minus I. Let's put the denominator now. 1 plus I times 1 minus I. It's going to get us that a minus b squared format, so it's going to be 1 squared, or 1, minus I squared. And that's going to simplify, but I'm just going to do everything out just for everybody. So let's multiply these 2 terms together. We're going to be foiling. 1 times 1 is 1. 1 times -I is -I. Positive I times 1 is positive I. And then I times I is minus I squared. That was positive I times negative I is negative I squared. Let's simplify our terms. Negative I times plus I cancel each other out. So we're left with 1 minus I up top over 1, that's this one right here, minus I squared. This is where this information up here helps you. It's what they gave you in the problem right there. That I squared is equal to negative 1. Of course, we all knew that from our preparation as well. So plug in a negative 1 right there. Alright, so now we can finalize our problem. 1 minus I is equal to 1 plus 1, right? 1 plus 1 is 2. So 1 minus I over 2 is our answer, which is D. Alright, so the last video we had a little bit of trouble with the audio, so I'm just going to reshoot this. I'm going to do it a little bit more casually too. I'm just going to try that style. I know no one's watching, so it doesn't really matter. So I'm going to jump right into problem number 3 for the imaginary numbers. For all x is greater than 0, which of the following expressions is equivalent to this guy, where I is equal to the square root of negative 1? So I is the square root of negative 1, that's what that says. And let's get our brush size down to the nice little 2 number. This says I over the square root of x minus I. Okay, so here we go. Which of the following expressions is equal to this? So there's nothing we can obviously simplify, and this is where we know that, multiplying by the conjugate helps. Multiplying by the conjugate is always something that's nice to do with i's. The ACT likes it. So up here, remember we can't change the original problem. We have to multiply by 1. So that's why I wrote root x plus I over root x plus I. Now we can multiply this out. So let's do step number 2. Let's multiply this in distribution. I times the square root of x plus I squared. And then we'll FOIL out the bottom. So this is x. Then we'll do our outside. That's plus ix, I root x, insides now. Minus I times root x is minus I root x. And lastly, we have last. So that's minus I times I, which is minus I squared. Simplify time. Up top, this is negative 1, right? And then this is not simplifiable, so root x, I root x minus 1. And then down here we have x, there's nothing else to simplify. And this is a negative 1, so this is negative 1, and that's a negative right there. So that becomes plus 1, right? That whole thing. And then let's look at the middle. Plus I root x minus I root x, they cancel out. So I'll put this positive 1 right here, and that checks off everything. Alright, this I think is our answer. So let's see. I think D or E. Let's see. E has I root x minus 1 over x plus 1. So E is our answer. So final problem. Which of the following expressions is equivalent to 49x squared plus 81? 49x squared plus 81, that is an a squared plus b squared format. We could rewrite it as 7x squared plus 9 squared. That's suspiciously similar to a squared minus b squared, which I know you get from doing like a minus b times a plus b. If you FOIL out this, you get that. Alright, but instead of a minus, we have a plus, right? Well, I know that if I have an I up here, if I have an I and it's going to be small, squeeze it in. Yeah, if there's an I right there, then I'll end up with an I squared right there. You can confirm that by FOILing it out, but you can take my word for it too. I won't mind. This I squared is a negative 1. You got a b squared, a minus b squared, right? Well, multiply these two together and you get plus b squared. Okay, so a squared plus b squared. Let's see if we have any answers that look like they're in this format, and we do, we have e right here. We have an a value, 7x plus 9i, and then 7x minus 9i. So e is our answer. FOIL it out, you'll see you get 49x squared plus 63xi minus 63xi. So those cancel out. And then a minus 9i times plus 9i is minus 81i squared, or plus 81. Okay, just as a final note on this problem, if during the test you're not going to be doing all this kind of theoretical explanation to yourself, my advice is to just start multiplying out the answers to see which one of these gets you the answer. It won't take you that long, and pretty quickly you'll be able to eliminate some of the answers. So if you FOIL out a, you'll get 49x squared plus 126x plus 81, and you'll say, okay, I got a middle term, and I'm going to get a middle term for b and c as well, so I'm going to eliminate b and c, which leaves me d and e. That took 15 seconds, and you are already at d or e, so that's a